Right, let's go. The perimeter then would have been, you take the expression, 10x plus 7, it equals 42, solve it. We've got 3.5. This should have been straightforward. Estimate for the mean. Find the midpoint of the first two numbers. You can add first and second number. 0 add 8 is 8. Divided by 2, get the midpoint of 4. 8 add 16, 24 divided by 2 is 12. Find the midpoints. Then times m times f. Midpoint times the frequency. 12 times 4, 48. 19 times 12, 228, and so forth. The total of the last box divided by the total of the frequency gives you the answer of 18.3. Right, easy one this. Just check the units every time you're doing these. So, that many kilometers divided by the time in hours will give you the average speed. So, 8760 divided by 9 gives you 973 and a third kilometers per hour. Straightforward on that one. Speed, distance, time. Next one. What we got here? Double bracket expansion. Easy this. I'll leave the answer there, working out there as well if you need it. Double brackets. Remember, term 1, 2, 3 and 4 times 1 by 3, 1 by 4, 2 by 3, 2 by 4, and then simplify. Use the calculator all times. This one here, Pythagoras' theorem. Have you got the hypotenuse? No, you haven't. So then you square, add square root, square 6, square 9, add them together, square root your answer. The answer should have been, will be on the next page. There you go. 10.82, just 2 decimal places. There's all you're working out if you need it. Cumulative frequency. So look, start with the first number. So it's 25. You add the next number. 25 add 36 is 61. 61 add 20 is 81. Keep adding first number to the next one. You get a total of 100. The total is usually what you get the first part of the word in 100. The midpoint, let's have a look. Has it told us to work on median? Yes, it has. The drawn cumulative frequency graph. I want to quickly tell you this. It's always the last. It's the last plot and then the cumulative frequency. So it's the last value. So here it would have been 20 in the answer, 30 in the answer. So the answer's at the top. The median, your total values are 100. You go to half of that, which is 50. Hit the line, read that value. It's 37. Number of students, number of teachers older than 45. Go to 45 this way because that's the age. Go across. It says here it reads 71. Anything above 71 to the total of 100 is older than, so it's 29. Right, first one straightforward. 3% per annum. Per annum means per year. You find the multiplier, so it's 2,500 times 1.03. Then times it by 1.03 again, or you could have just one calculation of 1.03 to the power 2 because it's 2 years. This one's a little more interesting. Here, it's only the compound interest, so it's 3,500. There's a multiplier with 1.065. Basically, it's how many times you keep timesing that by until you get that answer, and you'll see when you get to 4 years, that's the answer. Trigonometry, I'll quickly write this up here. So when you label all this up, sorry the right angle's moved, you would have seen that the line that connects the angle and the right angle, that right angle's going to be there. That's the adjacent. Opposite the right angle is the hypotenuse. It's going to be the cosine rule because it's got A and H in it. You're looking for an angle, so it's going to be shift cos to the -1, the adjacent divided by the hypotenuse, and you would have got your answer, which will be further down, I think. That'll be on the next page. There it is. There's the answer for the previous one, 38.94 degrees. There's another trick question here. I don't know why this is all messed up. It looks like, well, let's just give you the answer. So y equals 9.3, and there's your working out. Sorry, it's distorted on my tablet. Stratified sampling. You see this word here? Let me quickly go over this. Right, so there it is. It must say stratified. There it is. See the word stratified, what they're telling you to work out. Female students, volleyball, there they've highlighted it's 34. You always do what are you looking for out of the total. At the top it tells you the total, 212. Sample size is 50. When you do that calculation, you get 8. You always round to the nearest whole number because it's people we're dealing with. Here, how many males in the sample? 52 add 25 add 29 gives you a total of 106. Divide that by the total times by the same sample size, 25 would have been the answer. Now this one, I don't really like their working out, to be honest. I'm going to give you my own. Basically, it says here, surface area, the area is 200. This one's 32. So what do we know? We know that 32 times the scale factor. So times the scale factor, that's going to be, let's say the scale factor is k. It's being squared because we're talking about area, equals 200. So we don't know what k is. So let's do k squared equals 200. Inverse the times it by 32 is divide by it. Now, if you go ahead and quickly do this on your calculator, let's have a look what you'll get. And you reach over to mine. So I'm going to give you the exact answer to this question because we know what we're doing after we've got the scale factor. So 200 divided by 32 gives us an answer of 6.25. So here we go, write that now. So k squared equals 6.25. So to get the scale factor k, we square root k squared. That means we've got to square root 6.25. So we're going to square root that answer, and we'll get 2.5. So the scale factor is 2.5. Now, that's the value of the length scale factor. Now, it says here we're working at the mass, so we need to cube this. So if we do 2.5 cubed, we get an answer of k cubed is going to be 15.625. We've got the mass of the bigger shape, which is 750 grams. So we're going to do 750 grams, and big to small you divide by the scale factor. So we're going to divide by 15.625. You get the same answer. Well, that's what they've got down anyway. And you'll get the answer 48. Same answer. You can follow their working out if you like. I reckon mine's a lot easier. Right, I'm going to leave this up. Basically, I'm going to leave this working up for a minute. And what you do when you get your answer, you'll get an answer of 20 yen when you've looked at all that. And you get that's straightforward for you, like just double bracket expansion. When you get that, you factorize it. So 2 bracket 10 n. You just write down like they've wrote here. That's 2 times whatever's in there. Since this number, whatever it's going to be, is a multiple of 2, it must be an even number. You can pause and copy down what you want there. I think we might just leave it at that, unless you want to quickly do these. Right, so I'll leave this answer up, 41.8, working out's there. This formula is on your formula sheet. It's for area of a triangle when it's not a right angle triangle. So your length, A is going to be one of the lengths and B is going to be the other. Whatever angle's there, it's going to be a sin angle. Next one, 10.8. This is a cosine rule again. This is on your formula sheet. 10.8 is your answer. You literally do the lengths like above squared plus the other length you've got squared minus 2 times the first length times the second length, whatever the cos angle is. That should be straightforward with your working out. And I think we shall leave it at that, unless I see one more I think you can do. Right, we'll leave this bounds one up. So, you're working out what you know. We've done this one in class, so considering bounds, so you've got to give one answer. Because it's not said upper or lower, give one answer that fits both rules, and it'll be 1.046. And this is, if you look here, on the first one for the upper bound, it's the biggest one the first one could be rounded to, which is there, divided by the smallest answer that C can be, which is there. Don't forget to square root the whole thing, you'll get that answer. Second one, it'll be the lower bound at the top and the upper bound of the second number at the bottom, because you want the smallest number possible. So again, small and big, big and small. So big and small when you're dividing for upper bound, small and big when you want the lower bound. You'll get the answer. We will leave it at that. Thank you, good luck on your exam. Let's hope all goes well.